Okay, let's go.
So welcome back from part A. We are now going to part B of the very paper that we did as internal mock, which I already introduced in Mbale Secondary School. So according to what is here, the information we have to use. According to modern stadiums, there is a need to have to roof so as to avoid weather interference. The field shall pass through point 1, 2, 3. The field shall pass through point 1, 2, 3, and it needs to be parallel to the roof, whose Cartesian equation is 5x plus 2y minus z equals to 5. X, y, and z are measured in kilometers. The distance between the roof and the field needs to be at least 180 meters and not more than 185 meters for feasibility. The engineer needs the equation representing the field, so there is a need to get the equation representing the field. Remember, they said the field passes through here. The field passes through this point and is parallel to this equation. This equation represents the plane, XYZ plane. So they are saying the engineer needs the equation representing the field and also confirm feasibility. The design for seats will be at an angle, the line x minus 2 out of 2 equals to y out of 1 equals to z plus 1 out of negative 5 makes with the field and should be between 30 degrees and 35 degrees. The engineer needs to know this angle for proper planning. So according to us, what the engineer wants us to do in the first slide, I say, help the engineer with the Cartesian representation of the field and verify that the roof and the field have applicable distance apart. So here what we are going to do is we are going to now use this point. We want to find the equation of the plane passing through point 1, 2, 3, and it is parallel to this. Parallel planes have what we call they have equal norms or the perpendicular vectors to them. So if any1 is the normal vector identified from the alternative plane, so that will be the coefficients of x, y, and z. So that is 5, 2, negative 1. So if this is from that, we know that for parallel planes, their norms are equal. The norms are equal. So n1 is equal to n2. So meaning this one still shall be equating to 5, negative 1. And then we can use that if I get r minus a and I dot it with the norm, this one should always give us a 0. The normal dot with the displacement vector r minus a, this one gives a 0, where r is any point x, y, z. So this is going to be x, y, z. I think we need to further define r to be our point x, y, z, capital R. So the small r is this vector here. So minus a, our a is 1, 2, and 3. So dot this with the norm, which is 5, 2, and negative 1, giving us a 0. So we are going to apply the dot product between this and that, and we equate to 0 to get the Cartesian equation of a plane. So this is something to do with algebra. So this is x minus 1, y minus 2, z minus 3, dot it with the 5, 2, negative 1, giving us a 0. So we are going to have 5 times this, that is x minus 1, plus 2 into y minus 2, minus 1 into z minus 3, giving us a 0. So if we are to work out, this will be 5x minus 5 plus 2y minus 4 minus z plus 3, giving us a 0. So the algebra we are doing here, I think it is familiar to all of us. So we have 5 multiplying x, this distribution, 2 entering, negative 1 upon entering. So here we are going to have 5x plus 2y minus z, negative 5, negative 4 plus 3. We are going to generate negative 6, giving us a 0. So this is the equation representing the field, because we had the plane, we had the roof whose equation was this, and this one will be representing the roof. So these are parallel planes. So there is a roof, and then there is of that same field. So we want to also confirm, so this one is the equation representing the field. So the engineer wanted that. So before we make the conclusion, they wanted us to verify the distance between the two, the roof and the field. So they gave us the condition that the distance should not go beyond a certain distance, which we are going to verify. So we need to get the distance between, of course, we have some plane up and some plane down. So whenever we want distance between parallel planes, there's a formula that we can use. So the distance here, we are going to look at the shortest distance, or what we call the perpendicular distance. One, if this is the roof whose equation was 5x plus 2y minus z equals to 5, or minus 5 equals to 0, and this is now 5x plus 2y minus z minus 6 equals to 0. To get the distance between these two, we can simply get the point from one, and then we get straight from the other plane. So already we're given a point on the field, which was 1, 2, 3. So we have a point here, which is 1, 2, 3. So we want to get the shortest distance of this point from that. That's called the perpendicular distance, which is given by d, is given by the magnitude of ax naught plus by naught plus cz naught plus d, and then this one will divide by the square root of a squared plus b squared plus c squared. So it's now we'll call the formula, then we substitute. So the distance will be our a, these are the coefficients of that, or the norm. So we have 5, and our x naught is 1 plus b, which is 2 times 2, which is here. Then plus c is negative 1. That is now correct substitution. Then z0 is now 3. And then plus d. Our d is negative 6. Divide this by the square root of a squared. Our a is 5. So it is 5 squared plus 2 squared plus negative 6, but squared. So this one, we ask the candidates to simply compute that distance, which will be 1 out of root of 30. And this one is in kilometers. However, to compare with the distance which they gave us in the equation, that the distance should lie between 180 meters and not more than 185, meaning we change this to meters. So our distance we convert it will be 1 out of root 30 times 1000. And now this one is in meters. So that distance now gives us something like 182 .5742. 5742. Now this is in meters. Now this distance here lies between 180 and 185 as required by the setter of this item. So from there, we can now have some conclusions. So we are going to conclude and say the Cartesian equation representing the field is, we state this one, and at the same time, we are going to say the distance between the roof and the field is 182.5742, which is applicable according to the engineer. He wants it to be like that. And lastly, that is part C of the same question. Task part C, we are just continuing. It's a smaller part, which they wanted us to by calculate recommend whether the angle that at which the seats should be arranged satisfied. So they wanted the angle between the line, which is x1, x minus 1 divided by 2 equals to z plus 1 over negative 5. Because they said that the engineer needs the equation representing the field. The design for seat will be at the angle the line this makes with the field. So they want the angle is task C, angle between this line and the plane. Which plane they are saying the angle between that and the field. So the field equation is 5x plus 2y minus z equals to 6 or minus 6 equals to 0. So the angle theta, if theta is the angle, so that angle will be obtained from 1. We need to get the direction here. The direction from that equation is given by the vector 2, 1, negative 5. And the norm is going to be 5, 2, negative 1. The coefficients. So the normal vector and then this. So we are going to define from n1 dot it with this. This one is defined as n, then the cos. It is so funny when you are looking at a line and the plane. We are going to now put a cos, but with the restrictions. This one will be cos of 90 minus theta. If theta is the angle between that line and that, so that will be cos of 90, because we always have a plane. A plane is just like a surface. Now if I have this as the angle that it makes 1, I have the normal vector, and I may also, because I'm going to use the normal vector, and then in this line, the equation of the line whose direction is given, then the dot product defines the angle between the two lines. So I'll use this as the angle. So if the angle between this line and the plane is theta, so the angle between the normal vector and the direction vector of that line, it is 90 minus theta. So the definition here is now interpreting the two lines here. Now we can further define this, and we say the n, we need to see the dot product is given by this, then this is the same as sine of theta. So many candidates always try to bring us to this level as quickly as possible. It has no harm. So we can then replace. So n dot d is now going to be replaced. Our n is 5, 2, negative 1. Dot with d, which is 2, 1, negative 5. And this is going to be 5 times 2 is 10. 2 times 1 is 2. Negative 1 times negative 5 is positive 5. And all of this gives 17. The magnitude of n times the magnitude of d. Magnitude of n is going to be the square root of 5 squared plus 2 squared plus negative 1 squared. Then times magnitude of d is going to be 2 squared plus 1 squared plus negative 5 squared. And this is going to be 5 squared is 25, 2 squared is 4, 1 squared is 1. So together is 30. This is also 30. So this is root 30 times root 30. So together we simplify this to positive 30. So by definition, which is here, it now implies by substitution, n dot d, which is 17, is equal to the product of this, which is 30, times sine of theta. So here the value of theta will just be the sine inverse of, I think there is something that should occur here, which is 17 out of 30, which somebody can simplify, and the angle that will generate here, we're going to have the angle as 34.52. So I can give a minimum 34.52. Can give a minimum of 2 decimal places. This angle is measured in degrees. So according to the engineer, the angle should lie between 30 degrees and 35. And here, the angle we have is actually true, according to this scenario. So by calculation, recommend whether the angle at which the seat should be arranged satisfy the condition or not. So since the angle lies between 30 and 35, then it is applicable. So that is the end of that item number 1, done at balances as internal exam. So the next video we are going to have in the other mock bodies. So tomorrow. So get in touch. This content here you can share with your friends out there who are also having a holiday at their places. When you are free, you can just interact with the video. It is free. You can watch at any time. You can pause, then try out the items, and that will help you to memorize or to revise. So it's just an added support for those who are doing the video discussions. Otherwise, for now, that is item number 1. So let's come back for other items. Just stay online and tap on the links that we shall share, subscribe.
Okay, let's go.